All right, we have 2, 4, 6, and 8, and we're going to talk about these and naming these polynomials. Okay, for the first thing, there is an x here, right? And it's x to the 0, right? So what kind of polynomial is this?
A monomial.
Constant.
It's a monomial, and it's a constant. Okay? Constant because it has a 0 power. Okay? It's a 0-degree polynomial. So this is a constant monomial. Okay? Now, what kind of polynomial is this? It looks like a trinomial because it's 3 pieces, right?
But no, it's a binomial.
But what is a type of... Is it a constant? Is it cubic? Quadratic?
Linear?
This is what we call exponential, right? Anytime you have x power, right? X power is exponential. Okay? This is what we call an exponential function. But the rules of polynomial are they have to have an exponent of 0, 1, 2, 3, any whole number, right? Any whole number which includes 0, right? Natural numbers wouldn't include 0, but whole numbers include 0, okay? So 0 is okay, 1, 2, 3, 4, but we can't have like not a number, which is, this is not a number, right? Okay? Because it doesn't put any constraints on it. There's no constraint on that x. It's actually a function with respect to x, right? So there's many numbers to that, but we don't know what numbers. They could be 1.2. If it was 1.2, would that be okay? No. Okay? So, it's an exponential function, but it's not. It's not a poly. It's not a polynomial. Okay? Then we look at 6. And we go, well, what's going on with 6? It looks like a quadratic trinomial, doesn't it?
No,
But it's not.
Why not?
Catfish.
Yes. Not quite a catfish, because it's not trying to be something it's not.
Yeah, it is if it's not what it is.
Well, it's showing it's a quadratic, but what happened here? Yeah. That's a 1/2 power, right?
Yeah, so it's like,
And anything to a negative power or 1/2 power
it goes out in the middle and just goes.
it's just not a polynomial. This again would be considered square root.
Yes.
Kill me now.
Okay. Now the highest degree is actually the second. That's why this one's kind of messy. This one would be really messy. This would be a quadratic that has holes in it.
What?
Yeah. Because there's parts of x's that can't be, when x is negative, it doesn't exist, right? So the whole part of x, it's the quadratic that as soon as it gets to the x, so it doesn't matter where it is. If it's here, it stops there, right? If it's here, right, it stops there. So it can go that way. But wherever its quadratic is, once x becomes 0, it can't go any further. Because it becomes undefined, right? Okay? So it's only a partial quadratic. Does that make sense? Alright. So it's not a polynomial. Okay? Next. This is the k, and it says that the k is a whole it would be good, right? What if k was 0? It's good. In fact, what would it be? If it was 0, it would be a constant, right? If it were 1, it'd be linear, right? X minus 1. If it were 2, it'd be an x squared, which is quadratic, right? So basically, it's a degree, it's a kth degree polynomial. Okay? So it depends on what k is. As long as k is a whole number, we're good to go. And it said k is a whole number. It's a constant whole number. Okay? So whatever k is, because it's a constant whole number, it's a polynomial of that k value because it's a whole number.
Like, why is the
That's
last
a
one
K,
polynomial?
like a K.
K.
Why
What?
is the last one a polynomial? I thought polys are only more than 3.
Oh, no, polys are not only more than 3. Polys describe anything more than 3, but actually polynomial would describe a monomial, because a monomial is a polynomial, a binomial is a poly, and a trinomial is a poly. They're just a polynomial isn't necessarily a monomial. Does that make sense? It's like a square is a rectangle, but a rectangle isn't a square, right? Okay, a square, right, has all the same sides are equal, and that's a rectangle. Because a rectangle is defined as 2 perpendicular sides, right, 4 perpendicular sides, where the opposite sides are parallel and perpendicular to each other. Okay, so that means that they are. This could be like this. That could be a rectangle, right? This side's longer, but it's equal to that side. These sides are different than those, right? But so these are congruent, but these are not to those sides, but they are to each other, right? That's a rectangle. With a square, so that's a rectangle, but a square says that they are all the same. So a rectangle is a square is a rectangle, but a rectangle isn't necessarily a square. And that's the same aspect that's going on here. A monomial is a polynomial, but a polynomial isn't necessarily a monomial. Okay? Good questions.